All right, y'all. So we are starting on molar concentration. If you don't remember, concentration is just how much of something you have in a solution. So you can think of like when you make Kool-Aid, if you got a bunch of Kool-Aid in there, it's more concentrated. If you have more water, then it's diluted. Same thing for this. They're just asking us to find, instead of Kool-Aid, moles. So consider a 1 liter solution containing 85.5 grams of Al2SO43, so aluminum sulfate, and 21.3 grams of Na2SO4, sodium sulfate. What are the molar concentrations of aluminum, sodium, and sulfate? Starting off with, let's do aluminum. First off, like we've been doing with stoichiometry, we got to go from 85.5 grams to moles, because remember, we need molar concentration. So if we set up our little dimensional analysis, 85.5 grams, Al2SO4, this is 3 right there, over 1 times, remember we're trying to get the moles, so 1 mole has to go up top, Al2SO4 3 over the mass of aluminum sulfate. So if we add up those 2 aluminums, and then we have to multiply that S times 3, and then the oxygen, the O4 times 3 as well. So we got 3S, and in total, 12 O's. So we go from here, 3 times, this is a 1 technically, 3 times 1 is 3S, and then 3 times 4 is 12 O's, 12 oxygens. So I already did all this. I'm not trying to do it on video. It's going to be 342.132. So 342.132 grams of aluminum sulfate. I recommend you try to find that same number though, just so that you know how to do it when you get to the test, and it's not something extra that you have to memorize. Because if you know how to do it, it's not something you have to memorize. So grams of Al2SO43 cancel out, and now we've got 85.5 divided by 342.132. Now, remember, we are trying to find specifically the moles of aluminum. So in this little configuration, I guess, Al2SO43, we've got 2 aluminums. So we got 2 mole of aluminum for every 1 mole of aluminum sulfate. Oh my God, there we go. So that's gonna give us our moles of aluminum. If we do that, go ahead and grab your calculators, 85.5 over 342.132 times 2 over 1, which is just 2. It's gonna give you 0.4998. 0.4998 mole of aluminum. Okay, so since we've got the weight of aluminum sulfate, might as well work out what that is. And let me just erase. So hopefully you took a note of this. If you watched the videos on stoichiometry, hopefully you did. I didn't make those for no reason. Then you already know what happened right there. Okay, so we'll do sulfate because I already know the mass, which was 342.132. We start off with the same 85.5 grams of aluminum sulfate because we're going to find aluminum. Check. Let's do 1 part of the sulfate. So 85.5 grams of aluminum sulfate over 1 times 1 mole of aluminum sulfate. There we go, 3, that's a 3, over the molar mass of aluminum sulfate, 342.132. Same thing, 342.132 grams aluminum sulfate. Oh my god, that's Al2SO4 3. No confusion here. We cancel out grams with the grams. Jesus. And then for every mole of Al2SO4 right, we've got 3 sulfates. So 3 moles of sulfate. Oh my god. Oh, we don't need this 3 anymore. 3 moles of SO4 for every mole of aluminum sulfate. Okay, so same process, but now it's 85.5 over 342.132 times 3, because we got 3 moles of sulfate. This should give you, I'm going to write it down in green so we don't get confused. This should give you a 0.7497 or 0.7497 mole of SO4. Okay, there we go. Slowly but surely. Then we can do the other thing that we need. The sodium sulfate, 21.3 grams of sodium sulfate. Again, trying to make some space here. 21.3, okay. So 21.3 grams of sodium sulfate. All right, over 1, oops, almost forgot, times the mole, right here, 1 mole of sodium sulfate over the mass of that sodium sulfate. So sodium is 22.99, so 22.99 times 2. Sodium, 22.99. The S is sulfur, which weighs 32.06. So plus that. And then finally, O4. So 4 oxygens. Oxygen weighs 15.999 or just 16. And you got to multiply 16 times 4. Add all those numbers up. And you get 142.036. 142.036. Hopefully that's right. Na2SO4. Okay. And now I'm trying to find the sodium. That means there's 2 moles of sodium, because right here we got a little subscript 2 mole sodium for every 1 mole Na2SO4. Okay, so we calculate 21.3 over 142.036 times 2, and it should give you something like 0.2999 moles of sodium. 0.2999 moles of sodium. Okay. Now, since I've got the weight already, 142.036, I'm gonna just erase this. Yeah, that's cool. Oh, I should have kept that too. Okay. Dang it, I know it's too late. 21.3 grams. We're starting just to get the sulfate. 21.3 grams of sodium sulfate over 1 times 1 mole of Na2SO4 Weight's gotta cancel out. Pop, pop. And then we get the number of moles of sulfate. In this case, we just got SO4, which is just one. So 1 mole of SO4 over 1 mole of Na2SO4. Okay, so 21.3 divided by 142.036 gives you 0.14996. Wait, should be green. 0.14996. Okay, so in total, right, our final answer, molar concentration of aluminum, sodium, and sulfate. How do we find molar concentration? Well, we just do moles over the liters. In this case, it's just 1. So once we find the moles, thankfully, they gave us an easy one. 0.4998 mole of aluminum over 1 liter equals M of aluminum 0.4998. All right, there you go. So molar concentration of aluminum. Sulfate, let's do sulfate next. Green. Gotta add up sulfate. So in the aluminum sulfate, we found that there was 0.7497 moles of sulfate, and in the sodium sulfate we found 0.14996. Add those up together and we've got 0.89966. So 0.89966 over 1 liter equals SO4 0.89966. Okay, I'm gonna make some space for my sodium. I'm running out of space. Okay, and again, we're just dividing moles over liters. So 0.299 mole of sodium over 1 liter. You're gonna get the same thing. M of sodium equals 0.2999. There you go. Okay, that's it. That's for the first one. Second question, calculate the molarity of chlorine ions. Yeah, chlorine ions in 250 milliliters of a solution containing 25.9 grams of NaCl and 0.155 moles of HCl. Let's do this one real quick. We got 250 milliliters of a solution containing 25.9 grams. It's going to write that down first, of NaCl over 1. Remember, we're trying to get the moles of NaCl. Then we can get the moles of Cl or chlorine. And then we can divide it by the liters. In this case, they give us 250 milliliters, so we're going to have to do a little work with that. And then, oh my God, thank God, they gave us 0.155 moles of HCl. So we don't have to mess with that. Just go from HCl to Cl. So 25.9 grams of NaCl times 1 mole of NaCl, and then the molar mass of NaCl. If we got over here, where's it at? We should get 58.44. Na weighs 22.99. Cl, chlorine, weighs 35.45. So we got 58.44 over 58.44 grams of NaCl. Here we go. Cancel this out. Cancel that out. So 25.9 over 58.44 times, we're not done yet, the 1 mole of Cl, because remember we only want chlorine, the 1 mole of Cl in the 1 mole of NaCl. So we cancel NaCl, we end up with moles of chlorine. If you notice, it's just 1 over 1, so 25.9 over 58.44 is going to give you your answer. 0.4432 mole chlorine. 0.4432 equals 0.4432 mole Cl. Okay, this one a little bit easier because we basically start from this little point right here. 0.155 mole of HCl over 1 times, remember we only want Cl, there's only 1 mole of Cl in hydrochloric acid and 1 mole of hydrochloric acid. So this cancels out, and we end up with moles of chlorine. So 0.155 times 1 over 1, that's the same thing, equals 0.155 mole of Cl. We add these up, okay, 0.4432 plus 0.155. Oh God, almost messed up. Okay, 0.4432 plus 0.155. We get 0.5982. Okay. 0.5982. I hope you guys can see that. I don't know if you guys can see it. Okay, divided by 250 milliliters. Wrong. Not 250 milliliters. We need to convert these 250 milliliters to liters. So basically 250 over 1,000. Because that's how many milliliters there are in a liter. So 250 over 1,000. 0.25, I believe. Damn. I'm pretty good. Okay, so 0.5982 over 0.25 liters. Liters, not milliliters in this case. So figure that out. 2.3928. Hopefully you guys already got all that. I'm gonna just write down what I have over here, so that I know you guys can see it. 0.5982 over 0.25 liters. That's the same as 2.3928. MCl. There we go. You might have to do a little negative sign on there. I don't really know, to be honest. Let's say yes. Let's put it on there. But then that means that I missed it on the first three aluminum sulfate and sodium. So maybe not. Okay, that's it.